Welcome to Nodevember day 6 with the magic word Rivetted. So this particular project, I wasn't sure how to begin. So I started with a star and a grid fillet, but that wasn't going to work. So I used my procedural rounded cone and thought about, okay, maybe if I just boolean some grid shapes, then I can do a iron pole. I wasn't really sure how I was going to make this piece. I wasn't very inspired by the word, so I just made an iron beam with some procedural setups using some basic math and map ranges, start, ends, build it in, extrude it out. And then I thought, now what? So in Bforartists, we are still working with SDF grid node icons, which I'm currently developing. So I wasn't sure how to do the booleans right, but I didn't want to go full on out. So I decided to do a mirror, extrude, join, and then merge together, and then convert it into an SDF grid with a nice shape. So the reason why I wanted this is I wanted a very clean mesh and an easy way into getting some displacement at the rivets. So I loaded my Smart Mesh Blend by Proximity asset to learn how I did the actual proximity detection, because I forgot how to do it and it's not obvious. So I experimented around to try get the proximity from a null or an empty without too much success. And then I take a closer look at what I did and try to go back, and then I realized, oh, it's simpler than I thought. So I figure it out and realize that the proximity needs to be done based on a certain domain type, and it was supposed to be set by face. But once I figured that out, I was like, oh, now I have it, the proximity set correctly. So now let's set up a line grid and use some cubes to create a new type of proximity that I realized, and then detect over the actual SDF mesh. So now that I have my base rivet size with some offsets and settings based on the values, I then try that out and to set up the detection of the displacement. So now I have like a white and dark value, so I can set the position based on the normal with this new type of proximity to kind of get the push in or out of the actual shape. I just have to make sure I push in or out in the correct direction with subtraction or expansion. So I can now change the scale of the instance shapes, align it to the instances with another instance on points on the same line for the actual rivets. So now I have rivets pushed into the mesh in 3D, and now I can do that. I can do the final render and the general look and animation. So I thought, now how do I make this look, and how do I show the actual design? So my initial iron bar shape was a bit too rigid or globular, so I made it a bit more finessed, and then I made another line array on a line array to get kind of a grid instance of the rivets over the actual piece of metal. So now I'm pretty close to what I want. The mat cap looks okay. I changed the angle, looked okay, kind of like a tower of metal. So now I thought, what about the animation? So in this case, I try to use procedural animation, where I take the frame, use a map range, which I saw other people do, and I set a map range start and end point to kind of get an ease in and ease out of certain values. For example, the start of the angle of the edges of the bolts, so they come in, and then I use another map range to get in a keyframe C and D to go out again with a similar system. At this point, I'm starting to think to myself, map ranging keyframes is almost the same as keyframing in the timeline, just with a different editor, really. So I thought, procedural animation is more of a unless you're doing like loops or modulos. I mean, similar thing as with modifiers and F-curves. So I decided to not focus too much on that, but for this one round, let's just add in a boolean with some extra cubes instance on the same grid to punch in some holes as the bolts come down. I wanted to add in an extra cylinder. I join it into the instance. I use my rounded cylinder as part of that, just join it in, use that as the actual shape. So now I have a rounded, beveled bolt with the I guess you could say the rivet. And I know with rivets you're supposed to have something on the other side. I didn't think of that. So now I'm thinking of the lighting. I just used a built-in galvanized material from Bforartists. I use my inherent material asset so that the material stack passes through to the generated geometry. Then I build a background. I thought, yeah, let's go procedural. I use simplex noise to break up a Gaber noise into light. I thought maybe sunset would be cool, but then I thought, wasn't so sure about that because the metal with the orange kind of looked not quite how I wanted it to be. So I decouple the sky from the color with the same technique of the camera ray that I've used in my other videos, and then I bring in some ambient occlusion into the material to bring out some more detail of the actual galvanized metal, and I put that into the bump and then throw in a bottom fill light with a kind of a grey blue sky on the grey metal, monochromatic almost. And then I think, what if I use the same pumpkin painterly effect? So now you can composite in your new trees as an asset for the compositor in Blender 5 and 5.1. So I thought, alright, let's tune the animation and use the same painterly effect from the pumpkin. So since I did this with like really big sizes, this piece of metal is maybe 6 or 7 meters wide. I couldn't get very clear depth of field, but whatever, let's just animate it and render it out now. And this is the final result. This was done within 1 hour. So I hope you enjoyed and learned something of like some quick Boolean math, some quick parametric instancing, and using different types of techniques to bring this out. A nice and simple one, but a fun one. Enjoy.